Good morning. I am Mr. Igmedeo Tamesis from Ordineta City National High School, and I'll be discussing polynomial functions. The competencies are understand, describe, and interpret graphs of the polynomial function. We have some points to remember. First thing to do is to check if the polynomial is written in standard form, meaning the exponents are decreasing. The behavior of the graph is dependent on the sign of the coefficient of the first term and the degree of the first term. Take note also that the function of x is actually y. Now, for the behavior of the endpoints of the graph, we have the following. If the coefficient of the first term is positive and the exponent is even, you should remember that the endpoints of the graph will rise on both the left and the right side of the graph. If the coefficient of the first term is negative and the exponent of the first term is even, the endpoints will fall on both the left and the right side. If the coefficient of the first term is positive and the exponent is odd, the left endpoint of the graph will fall to the left, while the right endpoint will rise to the right. If the coefficient of the first term is negative and the exponent is odd, the left endpoint will rise to the left and the right endpoint will fall to the right. Now, for the intercepts, multiplicity, and turning points, we have the following. If the intercept points where the graph will cross or touch the x and y axis, the y-intercept is the maximum or the highest value of y. For the multiplicity, especially on the x-intercept, it will determine whether it will pass or touch the x-axis. If the number of multiplicity is odd, the graph crosses the x-axis. If the multiplicity is even, the graph touches the x-axis. For the turning points, it is dependent on the exponent of the first term. We subtract 1. We now proceed with our first example. This is for activity 1. So, the first term has a coefficient that is negative. The exponent is even. The turning points, based on the exponent, which is 4, we subtract 1, we have 3. So we have 3 turning points. So you have this graph. We have the second example. The first term, coefficient is positive. The exponent is odd. So we have the exponent of 5 minus 1, so we have 4 turning points, and we have the graph looking like this. We now proceed with examples for activity 2. So, given function ax is equal to the binomial x plus 1 multiplied by binomial x plus 2 multiplied by the binomial x minus 2, we are going to determine the intercepts. For the x-intercept, we set y to 0. So we have 0 for the values for the y. So we have the 3 binomials. We just compute for x plus 1 is equal to 0, x plus 2 is equal to 0, x minus 2 is equal to 0. We now have the following values. We have x is equal to negative 1, x is equal to negative 2, x is equal to 2, and these are your x-intercepts. For the y-intercept, just set x to 0 or substitute the value 0 in all x in your equation. So we have 0 plus 1, 0 plus 2, 0 minus 2. Further simplification. So we now have y is equal to negative 4, and this is your intercept for the y. Second example, we have the function of x. Gx is equal to x multiplied by the binomial x plus 5 multiplied by the binomial x minus 5. Again, for the x-intercept, set y to 0. So we have the following. 0 is equal to x multiplied by the binomial x plus 5 multiplied by the binomial x minus 5. So we have x is equal to 0, first intercept. Then we have the two binomials. X plus 5 is equal to 0, x minus 5 equal to 0. So we have x is equal to negative 5 and x is equal to positive 5. For the y-intercept, we have to set x to 0. So all values of x will become 0. So we have y is equal to 0. Third example, if we have the function of x is equal to a quadratic, x squared minus 3x minus 10. For the x-intercept, again, set y to 0. So you can use factoring or the quadratic formula to find the roots. By factoring, we have 0 is equal to the binomial x plus 2 multiplied by the binomial x minus 5. Equating it to 0, so we have x plus 2 is equal to 0, x minus 5 equals 0. We have the values x is equal to negative 2, x is equal to positive 5. So the x-intercepts are negative 2 and positive 5. For the y-intercept, set x to 0. So you substitute 0 in the quadratic. So we have y is equal to negative 10. It is now your y-intercept. Now this is for activity 3. Example for activity 3. We have the function gx is equal to the negative of the binomials x plus 2 multiplied by x plus 1, x minus 5. So we are looking for the endpoints or the behavior of the endpoints. So we expand only to get the first term. So the coefficient of the first term is negative. The exponent is odd. So it is raised to 3. There are two turning points. So the graph will rise to the left and fall to the right. For the intercepts, we equate again y to 0. Take note that the negative sign is present in all the factors. So we have the x-intercepts to be negative 2, negative 1, and positive 5. For the y-intercept, you just set the values of x into 0. Do not forget the negative sign. So you have the value of y to be 10. So there are 3 roots. So it is a cubic. So n is equal to 3. There are 2 turning points. The graph will fall on the left and rise to the right. So we have the x-intercept. So just like before, we just have to compute for the values of x. So we have the intercepts, 0, 1, negative 2. For the y-intercept, set x to 0. So y is equal to 0. So we have the third example. The function of x is equal to the quantity x plus 1 raised to 2 multiplied by the quantity x minus 2 raised to 2. From here, you will see there are some multiplicities, namely in x plus 1, it is squared, and x minus 2, which is also squared. Once it is expanded, we have x raised to 4 minus 2x raised to 3 minus 3x raised to 2 plus 4x plus 4. But since we are only interested in the first term, we have an even exponent. N is equal to 4. Therefore, there are 3 turning points. The graph will rise to the left and left and right. Since the multiplicities are even, therefore the graph touches the x-axis at this point. We now solve for the intercepts. So we have x plus 1 is equal to 0, x minus 2 is equal to 0. So we have x is equal to -1 and x is equal to -2. That is taken 2 times. For the y-intercept, we set x to 0. So we have y is equal to 4, which is now our y-intercept. And that is all for the activity.